Benzene is a colorless and highly flammable liquid, and it's actually a natural component of crude oil. The main use of benzene is as a chemical precursor for things such as nitrobenzene, which I will show how to make in another video, or for things like styrene, which are used to make polystyrene, also known as styrofoam. In this video, we're going to use sodium benzoate, which is actually a food additive, to make the benzene. Sodium benzoate is really nothing more than a benzene ring with a CO2 molecule attached, and we're going to use base and heat to tear off this CO2. I find it interesting because benzene alone is a carcinogen, but with the CO2, the sodium benzoate is actually a very safe food preservative. The chemicals required for this experiment are pretty simple. I used 100 grams of sodium benzoate and 60 grams of sodium hydroxide. This ratio of sodium benzoate to sodium hydroxide was found experimentally by the user Organicum on the Science Madness forum. To a mortar was added 100 grams of sodium benzoate. Then, using a pestle, it was crushed as much as possible. I kind of overloaded the mortar here, so it's a little hard to crush, but eventually it worked out. Alternatively, a coffee grinder could have been used instead of doing it by hand, and the easiest method is to simply buy sodium benzoate in powder form. After enough grinding, eventually we were left with the powder. Next to grind was 60 grams of sodium hydroxide beads. Here the mortar is much less full, so it was a lot easier to grind. Eventually, nearly powdered sodium hydroxide was obtained. With the previously crushed sodium benzoate in a beaker, the sodium hydroxide was added on top. Using a metal spatula, it was mixed a little, but I found that it was not very efficient at mixing. Instead, I opted for the Ziploc bag technique, where the powder is simply poured into a Ziploc bag and it's shaken until it's thoroughly mixed. The mixed powders were then added to an empty paint can. You can see here that the powder only fills about a fifth of the can. The paint can lid was placed on top with a pre-made hole. This hole was made by simply hammering a screwdriver through the lid. Then, a glass adapter with a generous amount of Teflon tape was stuffed into the hole. It was made sure that the seal was as tight as possible. Then, a simple distillation was set up, where a camping stove is used as the heat source. For obvious safety reasons, the setup was moved outside. The propane heater was turned on medium, and this began the distillation. Eventually, white vapor was seen. Soon after the appearance of the white vapor, some yellow, cloudy distillate started coming over. As the distillation progressed, the vapor got thicker and thicker. In this reaction, what's being carried out is known as a decarboxylation, and the overall reaction can be seen above. The reaction occurs between the sodium benzoate and the sodium hydroxide, and with heat it produces benzene and sodium carbonate. The sodium carbonate is a salt and it stays in the can, and the benzene is boiled off. I've color-coded some of the atoms so you can see where they end up in the final product. The rate of the distillation was adjusted so that all of the cloudy vapor was condensed. The heat was adjusted so a steady rate of distillate came over. When the heat was set too high, some of the cloudy vapor escaped past the condenser. The distillation was considered complete when no more distillate came over. At the bottom of the can, I was left with some very hard black salt crust. With some effort, the can can be cleaned out and reused for more distillations. This is the crude yield of benzene. You can clearly tell by its orange color that it's not pure. The benzene was then transferred to a separatory funnel. The benzene was then washed twice with 20 milliliters of water. You'll actually probably notice that there was already a little layer before the water was added, and this is due to the water that came over that was present in the sodium benzoate and the sodium hydroxide. After each addition of water, the separatory funnel was capped, shaken, and vented, but for time's sake I don't include this footage. Each time, the lower water layer is discarded and the upper orange benzene layer is retained. These washing steps may or may not be required, but empirical evidence has suggested that washing it can actually lead to a purer final benzene product. The benzene still likely contains a small amount of water, so it's transferred to an Erlenmeyer flask containing calcium chloride to dry it. The benzene is swirled and allowed to sit with the calcium chloride for several hours. This now much drier benzene is then transferred to a round bottom flask for distillation. A distillation is carried out to separate the benzene from the crude. The only fraction that came over was around 79 to 80 degrees Celsius, which corresponds well to the boiling point of benzene. After the distillation in the distilling flask, we're left with a small amount of orange liquid. In the collecting flask, we're left with some nice crystal clear benzene. In the end, I had a yield of about 43 milliliters. The amount of benzene that was obtained corresponds roughly to a yield of 70%.
سقفة يا جدعان. طلع